Hello everyone. I am Abir EL-ARABY, a third year PhD student at Sidi Mohammed bin Abdullah University, and I have the honor to present you my work entitled Chitosan Effect on Fungal Strains Responsible for Strawberries Post-Harvest Losses. Strawberries are susceptible to mechanical injury, physiological disorders, and fungal deterioration during post-harvest storage. However, these are highly perishable and die rapidly after harvest and therefore have a minimal shelf life. Recently, the edible coating has attracted a lot of interest as an effective way to extend fruit shelf life. The use of bioactive compounds such as chitosan is a typical example of edible coatings to control post-harvest losses. Current study highlights chitosan's negative effect on fungal strains growth responsible for strawberry fruit post-harvest losses. This work aims to solve one of the principal causes of strawberry fruit deterioration, which are sensitive during storage. Plan is as follows. Chitosan extractions. Extracted chitosan characterization by Fourier Transform Infrared spectroscopy and Scanning Electron Microscopy. Chitosan effects on strawberry spoilage fungi growth. And finally, growth rates modeling of tested strains in response to chitosan. Chitosan extraction was carried out from shrimp shell marketed in Morocco. Shrimp shell were washed, dried, and ground. The deproteinization process was carried out with powdered shells using NaOH at 5%. The discoloration was done with pure acetone for 24 hours. The colorized product was demineralized using 1% citric acid for 24 hours at room temperature. Purified deacetylation was performed by using NaOH at 55%. In the present study, chitosan extraction involves inorganic acid, which is citric acid for shrimp shells demineralization. The use of an organic acid is more environmentally adequate and significantly reduces production costs, unlike mineral acid application. Prepared chitosan was characterized by Fourier Transform Infrared spectroscopy and Scanning Electron Microscopy. Spectral data of chitosan extracted by citric acid exhibits characteristic absorption bands. Fourier Transform Infrared spectroscopy confirmed the presence of the amino group in the obtained chitosan. A deacetylation degree of 83% was calculated from the infrared spectrum. Morphological characteristics of extracted chitosan were studied by scanning electron microscopy. Figure reveals the surface morphology of chitosan extracted by citric acid at 10 micrometer and 5 micrometer. Chitosan micrographs showed very smooth surface and fibrous structures. A scanning electron microscopy image reveals the fibrous nature of obtained chitosan. Tested molds are strain isolated from spoiled strawberries. Chitosan antifungal activity on Botrytis cinerea, Aspergillus niger, Rhizopus stolonifer, and Penicillium spp. Mycelial growth was evaluated on PDA solid medium. Inoculation was done by depositing aseptically 5 mm of the previous culture on a culture medium containing increasing chitosan concentrations from 0 to 3%. Growth kinetics were determined by measuring mycelial growth diameter. These growth rates were calculated by the following formula. The following figure represents the growth rates related to chitosan concentrations. Chitosan reveals a strong antifungal activity, dose dependent from 0 to 3%. on all fungal strain growth. 3% of chitosan concentration gives a total inhibition of mycelial growth. Chitosan extracted showed a negative effect of fungal strain growth isolated from spoiled strawberries. These biopolymers can significantly reduce the microbial load of strawberry fruit's deterioration. Mold strains were the subject of mathematical modeling of their response to chitosan as an antimicrobial agent and strawberry fruit as the matrix used. Chitosan effect on growth rate is translated according to two models: a linear model reflecting a specific resistance of Aspergillus niger and Rhizopus stolonifer, and a polynomial model representing a sensitivity of Penicillium spp and Botrytis cinerea strains. This difference reflects a structural difference in tested strains walls. From this illustration, can be concluded that the growth rate model depends on taxonomic position of tested strain. Development of drought caused by fungal pathogen is one of the major causes of post-harvest losses in strawberries. Chitosan extracted showed a negative effect on fungal strains growth isolated from spoiled strawberries. As a perspective, we plan to extend our study by a post-harvest treatment of strawberries with chitosan as a coating solution to prolong the conservation of these fruits considered sensitive during storage. And let's recycle the co-products of this tea, please. And thanks for your attention.